Good morning, everyone. Welcome here for the first talk of this day, third day. You're still fresh and energized. And you may know E.ON in these red colors as a company first selling electricity across Europe. It is the probably first idea you have in your mind, or an old hardware company managing a lot of energy networks, replacing fuses, climbing pylons, and doing a lot of hardware stuff. But actually, nowadays, E.ON is more represented in the cyberspace because we have to manage somehow this infrastructure, and the infrastructure got smarter with every day. We get smart meters. We can offer a lot of plans for our customers, cheaper, more expensive, but more stable. Reliability is a very interesting topic because we have multiple suppliers on the market and everybody can sell the electricity to the grid. You need to think about the congestion problems when at some point you have our produced state and you need more consumption somewhere else, hundreds of kilometers away. And all these problems match actually very well on the topics we would like to present you today. The topics for today are how we can manage the load in this world, information load for the customers and for the employees of E.ONs, and one of the very important topics here, how to do it efficiently. The efficiency means you don't have to waste your resources. E.ON is very cautious about not producing more and selling more, but doing it environmentally friendly. That's why we don't want to call our LLMs too often and sleep well at night for these reasons. If we look at the last years, meanwhile, 4 years back, LLMs pioneered a very interesting class of applications. We do not take seriously the necessity of training a new classification model for customer feedback text, for example, or we do not provide our custom models for extraction of personal information from texts we get every day in the emails or in the transcribed voice messages. We do not try to write emails blocks for the customer support. We all delegated it to some cryptical model which lives somewhere in the cloud, and we aim for the newest one always. Through the information there, hope for the best and get some result. But the reality is, in this shiny world, very simple. This gets very expensive. And after 4 years, we have a very clear statement. The AI cannot burn more money in the real sense of this world than it saves in the end. In the last 4 years, we went through a very clear evolution, starting in the 2023 with a very simple RAG applications. We took models at that time, it was OpenAI GPT 3.5 family. We took a lot of code from Microsoft. E.ON is a Microsoft shop to biggest extent, our 90% of all our code is running in the Microsoft code. We used a lot of predefined path on the Azure cloud using, for example, document intelligence and AI search and not bothering with other vector and databases. And we had a lot of ChatGPT-like functionality for internal users of us, not for the customers. E.ON does not offer any digital solutions of this kind to the outside market, but we automate our internal work a lot. And then we went next year to the point where we battled a lot with external sources, not only using the sources provided in the PDF documents with very simple ingestion pipelines or the model knowledge. We tried to give the chance to the model to learn from our SharePoints, for example. And in a big corporation, it is not easy to get all the permissions and combine all the sites of SharePoint to one big mesh. Another pain was definitely handling non-English input. We have Hungarian customers, we have Romanian customers, we have definitely people from Sweden and Italy, and it made our life much more complicated. And having learned that, Jenny is laughing, much more complicated was her work, working with Hungarian customers. The next year was actually the idea of doing not only a single application, but combining it all into backends, which can be called from anywhere, and custom frontends were a very important step where we offered centralized services across E.ON for people who would like to build their own information retrieval solution. And for that, we had our AI hub hosting very different LLMs behind it. The GenAI architecture from that made us cautious that we do not need to only give access to the models, but give all this stack and make some elements of this stack inevitable if you build new application. And I would like to point your attention to observability today, because it is a point which is mostly neglected if you build a fresh POC. You look at your logs, you try to understand what is happening, but in the end, the system evolves. And today I and my colleague Evgeniya will show you mostly how this evolved system can look like, how bad things happened to us. These systems were built overnight and then evolved over a month and then landed in a situation where they were not efficient anymore, and how we circumvented a couple of problems. Talking about the architecture, retrieval and evaluation, we can look at the generalized architecture of a retrieval system at E.ON. It is not one specific project, it is part of the architectural board overview where we can see that we tackle multiple sources in two phases. The runtime, where we get answers generated on the bottom of the slide, and actually the whole magic happens previously when you extract data from different sources, running it in batches, for example, on Databricks or in custom pipelines in our Kubernetes clusters. And as usual, looking at the bottom and the green bar, you see the magic word LangFuse, the mostly used solution for observability in our in-house solutions. It came up not from a sudden here, it was a learning that without a system for this functionality, you cannot understand what happens to your system. LangFuse is not necessarily one solution, and something bad happened to our video signal. I can entertain you in these 2 minutes, telling you jokes about how the cockpits are, but the signal is back. LangFuse is not only the one solution. I can show you a very quick commercial overview for that, starting with OPIC, which is a very widespread solution on the UK market, E.ON Next. And E.ON UK use this cloud provider for observability a lot. We'll be talking about the functionality on the next slide. A very reliable partner for us if you're not concerned with storing your data definitely in the European region, and you can outsource to the US, which is possible for our UK departments. The next very widespread solution is definitely LangFuse. Open source solution with a big office in Berlin. You can talk to these people directly, they are approachable. and they did the exit a couple of months ago very successfully, and were bought by ClickHouse after they reviewed all the architecture to the ClickHouse backend. And the next one is the solution, which is probably known to everybody in this room, is MLflow. If you have a Databricks background or you have ML Studio running somewhere and do not want to have a third dependency, again, go for extended functionality of MLflow. But those were commercials of the systems. Let's look at what is important actually for us as people who operate these systems. First of all, we do want to understand how the input and output of the LLM looks like. Tracing and tracking of single spans and requests. We do want to annotate every span if we would like, if they are problematic, to custom data sets and run experiments on them, calculate scores. One of the examples for this course is on the left. And definitely you would like to compare after deployment the performance of your system based off the predefined golden data set uploaded to this tool. You can manage your prompts. Mostly we do it on the code side and synchronize it to the UI of LangFuse to enable our non-that coding affiliated people to do the experimentation on the LangFuse UI. And a very important thing for the management is actually the cost breakdown, because you don't understand your costs for the LLM or specific path for optimization if you look only on the Azure cost panel. But let's look now at the things which can definitely go bad in the system. These two examples I will be showing you now are not created from scratch. I mean, nobody would go into this situation willingly, but if you do it in a team which evolves and new people come in and you don't look at the behavior in the production, sometimes you can get a situation when you try to generate an answer and then you run obvious checks in parallel. In this depicted case, you have the check for faithfulness, how trustworthy your answer is, the correctness, if you can actually compare it to the golden truth in this case, and the hallucination rate. And understandably, if you would like to force your generation into a state to give you more details, the hallucination rate rise up because the model gets creative. And if you force it to write more text, it writes it, but not necessarily based on the text. In this case, you may end up with the endless loop. The loop is definitely not endless because you have some retry count and you exit after 5 times calling your model, but you end up with a situation where one check with one prompt forces to do the opposite as the other check. In this case, we have the trade-off between the hallucinations and faithfulness. Another example could be if you do not differentiate the error mitigation techniques here, and in all the consequent checks after the generation, you always exit if your check fails after some time of retries, and your user and badly your logging system does not understand what is the point where you exited. How to fix this state? Fixing this state means that we definitely need to observe the system and see what happens on the trace level and then handle it. How we can handle it, Jenny will explain you in 2 minutes.
Is it working?
Somehow not.
Okay. Yeah, so as Andrei has already mentioned, we have various projects related to different RAG systems. So in this graph, I show more or less the possible issues that Andrei has already discussed in details. And basically, to tackle it practically, we need to first formulate the issue. So basically that the long dialog graphs might accumulate various pathologies, such as death path or infinite loops, all that Andrei has already discussed. And what we want is actually to reduce those graphs by adjusting maybe some thresholds for evaluation or restructuring the node system. But before this, we need to ask us several questions. So first of all, if this graph should happen at all, if in this way. So if we need the retrieval at all. Because, for example, there are often some questions, not questions, but queries from the users, like, for example, hello, or some polite form, or some malformed questions like what is. And this can actually be a problem because in our early systems, when we always did a retrieval, because, well, it's RAG, we need to retrieve the documents, exactly this what is was working very badly because we did retrieve some documents and there was just some very weird answers. It can also be a question that more complex case. For example, we need to disambiguate the question because, for example, if in a system we have information about several departments, and the question is about, please tell us about the traveling guidelines. The question is okay generally, but exactly this system should first understand about which department it goes, and so it should also ask the question. So please make it more precise. Or there can be also some questions that are certainly not about our documents, and those would require, for example, web search. It can be a question like, what is the weather today? And it's obvious that we also don't need to do the retrieval. And we have different systems. Some would contain web search, some would not. If it does contain it, we can go in that direction. If it doesn't, then we should just finish the graph and say, well, sorry, I don't have this information. Another question is how much history or conversational context we should use. If because it is very token consuming, if you have a long history, maybe we should use only last several sentences, maybe we should summarize it. Maybe we can also check the query and then we would know that it doesn't have to consider the history at all. For example, if it is again, just thank you, okay, thank you, we don't need a history for this. Or we know that the new question doesn't have anything to do with the previous one, because some users are working just in one chat and it is actually very confusing for them when the history is too much present in the chat, because we often had also questions, for example, if I start a new chat, I have this answer, but if I somehow do it in the old chat, it's completely different answer. And of course, yeah, there is a question of how we do the quality check for the answers, how high is the threshold for the evaluation, how good basically the answer should be. And it can also be considered differently because, for example, correctness. We have an example answer, but it actually can also be correct when the answer is quite different because the user who created this data set didn't think of a different answer based on the document base. And when we considered all of this, we can start creating a new, cleaner graph by tweaking all those thresholds as well as restructuring the nodes. Here, for example, we see that for certain questions, we would just go directly to the answer using LLM and without executing all of the graph with the database calls that are also actually very time-consuming and expensive. And so our method would be keeping the redundant graph and compare certain metrics for the redundant graph and for different options for the clean graph. So basically, we did it automatically, partially, using something like auto research. We had some skill files that would adjust some parameters of the graph. And so when we have the answer, first we need to evaluate like in any RAG system, because evaluation basically defines the success of our project, how good the answer is. If it is correct, if it is well-grounded, if there are hallucinations, and if it is actually useful, because it can be perfectly based on the documents, but not really on the point to the question. Then, of course, there is a question of latency, efficiency, depending on the use case. The answer should be, it is crucial that the answer is fast and our users not getting annoyed. For our system, it's very important that the answer is really thorough and thoughtful, and then they can also wait for 5 minutes because before the answer is there. But exactly for our use case, it is also important to have a good routing quality. Basically, that is something that we are going to evaluate here. So how many dead paths are there, how deep the graph is, how many LLM or database calls we had. And basically, so here we evaluate at each experiment step our outcome quality versus the routing quality. if some reductions in the graphs affecting our results in a better or worse way, because we can reduce the graph completely. It will be very fast and nice, but the answer quality will be horrible. And then would like to show just a very small demo. Basically, it is exactly where we compare. Sorry, I don't see my mouse. Yeah. Oh, sorry, now it's here. I'm sorry. Yeah, so right now here we use just more or less generic Jupyter notebooks, because for different projects we use different observability systems like LangFuse, OPIC, and ML flow, as Andrei said. And here basically we can see that when we run it, we execute our graphs, and we, wait a second, we execute it, and I think my token has expired, but we'll still be able to see something. Wait a second. Yeah, demos as usual. Sorry. Yeah, I can show it. And here, before the token has expired, it was working. Yeah, I can show you the result then. So basically, it builds our graphs, and we get such tables. Here we see the query, and the comparison of the clean and redundant graph. So basically, we can see how many retrials there were, how many generations there were, and their LLM calls. For example, in many cases, it's going to be the same, because maybe the questions are straightforward or too complex. That is why here, for example, we have the same LLM calls. But in this case, we see that we have 3 LLM calls, which can also already be a lot of time saved. Then we can also build the graphs. That was actually doing the node that didn't work because my token has expired. And yeah, so here we see, for example, that for clean and for redundant graph, it was the same because the question was very ambiguous. But in this case, for example, we can see that actually the clean graph didn't do too many checks and didn't go into the loops because the question was, answer was good enough. And the redundant graph had built already a lot of looping, trying to improve the answer that was already good enough. And basically in this way, we can continue and see with different parameters how it works. And yeah, so in this case, we continue developing our graphs. And we actually, so it sounds a bit theoretical, but it is actually the approach that we use in various projects related to our customer emails or some chatbots that we use for our customers with their internal systems or some internal documents that they have. So yeah, thank you very much.
So super nicely done. Thank you for the nice talk. I think there's your LinkedIn. So
yes.
Feel free to connect with the speakers, or also feel free to pick up the speakers after that for like simply asking a question personal. So we have some question already there at talks.pycon.de. So I will start now with the first question, and this is a side question. Which LangFuse version do you use? The self-hosted one? If yes, what is your experience regarding the cost of it?
I can answer this question because I was a lot concerned with different installations exactly of LangFuse. Currently, we are in the middle of a migration between the second and third generation. It is not very straightforward because of this big architectural change. I would say that it is affordable both in a cloud and a self-hosted scenario. We are happy with that. The only problem is that you need a dedicated team who would look after this installation. That's why we definitely would like to centralize that. Not every team needs its own installation of LangFuse. We have now 3 bigger of them, like the, for example, installation of EDG, Eon Energie Deutschland GmbH and the centralized EDT installation for E.ON Digital Technology, which is the hub of technology for the whole E.ON, and definitely a couple of widespread installation. Though centralization here is, in my opinion, the key.
Super, thank you for the answer. The next quite upvoted question would be, do you try agentic architecture which overcomes the DAG approach completely? Direct
Which?
The agentic architecture, which overcomes DHT.
DAG. Direct
DAG. Okay, direct acyclic graph. Okay. I mean, we have a lot of agentic components in the racks themselves. They decide on themselves which part of the system needs to be called, especially if you have tasks, in this case, conversational task, retrieval task, or actionable task as well. Yes. For information retrieval purely, where you have especially different types of documents, you can do it deterministically better, in our opinion. Not let to decide the system.
It depends. It's a little bit on the project, because we also did some demo. It's not in a real project, but where we didn't use only this vector search, but also built a graph based on the data. So we will combine the vector search and this graph. Since the document base had a lot of somehow interconnected documents. And for build this graph, we actually also used some agentic approach. But usually it is, the agentic part is mostly in the part after the documents are already there and processed.
Super. Thank you for your answer. The next question will be, will you share your slides?
We will.
Yes, sorry.
So, like pre-text or?
Yeah, we've forgotten to upload them to pre-text. They will be available shortly after talk.
So I think you can also upload them to the Discord channel and the slide channel, so maybe it's also easy to spot them. Thanks for uploading the slides then. So the next question would be, how do you tell what is a redundant graph? Did I understand it correctly that you look at the intermediary generations to figure out when a response would have been good enough without any additional LLM, large language models calls?
Well, about the redundant graph, so usually we just observe it. For example, in a certain project, we observed it in length views, and we saw that there were a lot of calls before we set a good threshold for the number of attempts. For example, we saw this infinite loop in the graph. Or we saw that, for example, we go through the whole graph and still the answers to general. That is why it means that probably it was some generic question and we didn't have to go through it completely. But yes, I think the easiest way is to observe it and see if there were some loops that were taken too long or some executions that don't lead to anything.
I see. Thank you. So another question. From your session name, you call it as don't call your LLM too often. Could you explain what it means? Are you referring to building a simple graph versus an redundant graph? Like simple versus redundant graph?
Yeah, it is the reference exactly to this case that we try to make the amount of calls as less as possible, trying to build the optimal shorter graph in this specific case, yes.
Another question. How did you measure correctness of the answer in the chat? Maybe longer graphs have better answers in the end. Was an assumption from the question, Oscar?
Yeah, it is exactly our problem with the correction. As I said, exactly this step is the trickiest one because the groundedness, for example, is clear if it is based on the documents or not. Or usefulness is also more or less clear, but for the correctness, we have some data sets where our users say what they expect. But yeah, as I said, often it is not correct actually what they expect because they don't know all hundreds of documents in the database. And yeah, probably there are some documents that actually answer the questions better than they expect on the documents that they think of. That is why exactly these parameters what we use for evaluation, but cautiously.
The last question will be, do you run any component level evaluation of a graph, or are your evaluations mostly targeting end-to-end quality?
It is a very tricky question because we're currently trying to modularize these approaches, and we have tests for RAG components specifically. If additional dialog component is employed, then it will be an end-to-end test. On the architectural diagram we showed you in the middle slide, you probably saw the RAG as an extendable component, and we try to pre-test them, let's say on the unit level. But generally the acceptance test will be end-to-end, having the friendly user group, and then testing from the front end to the retrieval back end, the 100% of the pipeline. So in the most cases, we are talking about the end-to-end testing.
Thank you for your answers. This was Evgeniya and Andrei with their talk, and I hope you as an attendees can now sleep better at night. Thank you.
Thank you.
Thank you.